This podcast is sponsored by Lamprobe. Lamprobe is a popular aesthetic tool that enables skincare practitioners to rapidly treat a wide variety of common minor skin irregularities, or MSI. Red MSI treated by Lamprobe include dilated capillaries and cherry angiomas, yellow MSI, cholesterol deposits and sebaceous hyperplasia, and brown MSI treated include skin tags and more. Lamprobe MSI treatments are non-invasive and deliver immediate results. Lamprobe can empower your skin practice with these new and highly in-demand services. For more information, visit lamprobe.com. That's LAMPROBE.com. And follow Lamprobe on social media at Lamprobe.
Welcome everybody to ASCP and the Rogue Pharmacist, Benjamin Knight Fuchs. Hey guys, in each episode, we will explore how ingredients, chemicals, and the environment can have a positive and a negative effect on the skin. And if I may take a minute just to remind all of our members to log in to ASCP Skincare on your phone and download the ASCP Skin Pro app. Now, you guys, it is not available in the App Store. I'm going to say it again. It is not available in the App Store because it is exclusive to members. The ASCP Skin Pro app puts skin conditions, ingredients, and their indications and contraindications in the palm of their hand for quick access in the treatment room or even on the retail floor. And by the way, I am Tracy Donnelly, Executive Director of ASCP, and joining me today and co-hosting is Maggie Staszcuk, our very own Education Manager. Hi, Maggie.
Hey, Tracy.
Hey. Okay, guys, we are going to be discussing today peptides. Are they just a fad or do they have a function? You know, you really can't go anywhere these days, like online, the TV, in a store, without seeing it splashed across a label. I mean, am I missing out here? Maggie, are you using peptides?
I am. It's in my creams. It's in my serums. And actually, in fact, I did used to use a cream, and maybe I'm insane, but when I would apply it to my face, I feel like it would make my eyelids twitch. I don't know if that's a thing.
That sounds crazy bizarre. I can't even wait to see what Ben has to say about that, Maggie. So on that note, let's turn it over to our expert. Welcome, Ben.
Thank you so much. And yes, it could be a thing. So let me just ask you guys, let me turn to the tables here. As a pharmacist, I often wonder what non-scientists think about some certain things, ingredients in general, but specifically real high-tech ingredients like peptides. So what do you guys think peptides are?
I'm just going to be honest. I mean, I just think, oh, it's an active ingredient. Let's slap it on my face.
Active ingredient.
Yeah.
Okay. Because the reason I ask is because they're super fundamental. Nothing happens in life without peptides.
Whoa.
They are the most fundamental molecules in biology. In terms of the skin, or in terms of the human body, in order to understand what peptides do and how important they are, you got to understand cells. Okay, so everything's about the cell. When we talk about the skin, unfortunately, we don't often talk about the cell. We talk about what we can see. But because everything we see comes from cells, you can't really have an effect on what you see unless you affect the cells. That's first of all. So you have 100 trillion. Nobody's really counted them, but
I hope not.
The conventional wisdom says between 50 and 100 trillion cells in your body, right? And somehow the body has to be organized such that they communicate to each other. They talk to each other. So a cell in your skin has to be able to communicate with a cell in your blood. It has to be able to communicate with a cell in your digestive system. It has to be able to communicate with all the different cells in your body. And this is usually accomplished with something called hormones. Right? And that's
those hormones.
Those hormones, right?
I love them and I hate them.
And that's what a hormone is. A hormone is a molecule that talks to cells. A hormone is a molecule that somehow communicates to a cell what's going on in the environment, either in the very local environment or even in the very distant environment. And so you have hormones that travel a great distance, and they usually travel through the blood. Those are called endocrine hormones. And those are the hormones we tend to think about when we think about hormones. Those are mostly your steroid hormones. And they'll go from your thyroid, for example, or from your brain, for example, to the various organs and tissues and cells of the body. Those are hormones, and those are endocrine hormones. But then you have another class of hormones that communicate locally. So a cell will actually secrete out a hormone, and then that hormone will turn around, do a U-turn, and communicate either to that cell or cells that are in the local environment. Those aren't called endocrine hormones. Those are called paracrine hormones or autocrine hormones. Paracrine meaning nearby, or autocrine meaning self. So you have your endocrine hormones and you have your paracrine hormones and your autocrine hormones. The endocrine hormones we're not going to talk about, but when you talk about peptides, what we're typically talking about are hormones that come out of a cell, do a U-turn back and go back to the cell, or affect the cells in the local area. Para meaning local, auto meaning self. So you got paracrine hormones and autocrine hormones. These paracrine hormones and autocrine hormones are made up of little chunks of amino acids, right? Little chunks of amino acids are called peptides. And so when we talk about proteins, and you had mentioned proteins earlier, proteins are lots of amino acids, 100 amino acids, 1,000 amino acids. Peptides, when we talk about peptides, we're talking about short chunks of amino acids. Dipeptides, meaning 2 amino acids. Tripeptides, meaning 3 amino acids. You've heard these terms probably. Pentapeptides, 5 amino acids. Tetrapeptide, 3 amino acids, that kind of thing. So these peptides function like hormones, which means they function like words. In fact, hormones are said to be a language, a cellular language, and peptides are said to be a cellular language. Right now, I'm talking to you. Words are coming out of my mouth, or actually air is coming out of my mouth, and then it's causing vibrations in your ear, and then it goes into your brain, and you make meaning out of those sounds. Well, cells don't have ears. They have little spaces for words to fit into those spaces. So right now, my words are coming out of your mouth, they're fitting into your ears and going into your brain. Cells don't do that. They don't have ears, literally. They have little spaces that function like ears. And those little spaces that function like ears are called receptors.
I love this analogy, Ben. This
right?
is good. I'm visualizing it.
You can visualize it, right?
Yeah.
Your ear is kind of like a receptor for my words, and a cell has little ears that are receptors for chemicals. The chemicals to a cell function like words to an ear. That's the analogy, basically, right? And that's why I had this book here that I'm showing you. We can see it, of course.
No, they can't.
The Secret Language of Cells, and how cells talk to each other and how they communicate to each other using these peptides, using these little molecules, is the latest and greatest in science. And we've only really understood this for we understood hormones for maybe 100, 150 years, but really the idea of peptides being a language for the cells really only got going about 30 or 40 years ago.
Wow, that's crazy in the skincare world.
And in the skincare world, it's even more recent. It's only about 20 years or so. In the skincare world, it was realized when they started to do genetic technology. I don't know if you remember the big genome project. Do you guys remember this?
Yeah, that sounds slightly. Yeah,
in the late 90s, they were really obsessed with trying to figure out what every gene in the human genome did. A gene is part of the DNA, and each gene is supposed to code for a specific protein. And they got really obsessed with trying to figure it out. And they thought it would take 50 years to figure it out. It turned out it only took 10 or 15 years. And by the end of the 1990s, they had mapped out the human genome, figured out which genes code for which proteins and which peptides. Genes code for peptides. Okay, so they matched up genes with specific peptides. And they had this map of all the genes and all the peptides. And then they said, well, what are we going to do with all these peptides and all these genes? And they started to explore using them in skincare products. And right around the turn of the 21st century, when the genome had been mapped, you started to see peptides being used in skincare products because they had figured out which peptides were associated with which genes, and they could produce them. They produced them with something called recombinant DNA, where they actually take the genes from your genome and put them in a bacteria and have the bacteria make all these peptides for them.
Oh, that's how they make it.
Yeah. And so it was really easy. Bacteria are cheap, and this was a cheap way to produce peptides. Before then, they had no way of producing peptides. They had to get them from animals. So now you had this ability to get them from bacteria, and you start to see peptides all over the place in skincare products.
So we're putting bacteria on our face?
No, you're putting peptides. You're putting peptides from the bacteria. Because what they do is kind of cool. What they do, they take a gene that's associated with making a specific peptide. So let's just say a peptide for causing pain. I'll tell you how these peptides work in a second. But say there's a peptide that causes pain or causes inflammation. They can take the gene from your genome and put it into a bacteria's genome, and bacteria replicate like crazy, and they make lots of stuff. So they just put in a vat of bacteria, and then they scrape off the peptide off the top.
Wow, I love that.
It's really cool, and it's really inexpensive. It's a really cheap way to make peptides. So what exactly is a peptide doing? Well, a peptide is sitting in an ear and making the cell do something. In fact, cells do everything they do only in response to peptides.
Okay, that's huge right there.
Yes, cells do all of their behavior only in response to peptides. This is why genetics is so important, because genes are how peptides are produced. But it was discovered that you could do it exogenously. in the skin anyway. You could take a peptide that was supposed to say, let's say there was a peptide that would open up, that would cause cells to produce collagen. Just to give you an example.
That sounds like a good one.
Right? That's a good one, right?
That's a good one.
And there are peptides that would stimulate collagen production. So they figure, well, if we take this peptide that stimulates collagen production and put it in a skincare product, now you have a peptide that's on the skin that theoretically, keyword there, theoretically, can migrate from the skin or the skincare product through the skin all the way down to the cells. And they'll sit in the ear of the cell, if you will, the receptor of the cell, and they'll initiate the production of collagen or elastin or moisture factors, or they'll make the cell divide, or they can support immune cells for inflammation, anything you want, really, because these are words. So you're basically commanding the cells to do anything you want. Now that sounds great.
I'm hearing the if. Though.
Yeah, there's an if there.
There's an if.
It's
There's a big
theoretical.
if. Yeah.
There's a theoretical aspect to it. Were you going to say something?
Well, no, it's just that. I heard you say,
Yes.
if you can get it down to that level.
Yes, because really, cells are not stupid. They're not going to just do their behavior just because a peptide is there. There are feedback mechanisms and fail-safe mechanisms that will prevent that from happening if it's not supposed to happen. So it's not the mere presence of a peptide that is going to initiate the chemical reaction or the cellular reaction. All of the extra steps in the environment have to be correct. There has to be enough nutrients. There has to be less toxicity. The cell membrane has to be intact. The cell has to be healthy. There's a lot of factors that come to play in determining whether a cell is going to respond to that command. If I say to you, Tracy, go get me a cup of coffee. I'm just kidding. But if I
Wow. I see how this is.
If I said that, you may not hear me. You may have the headphones on. You may be busy. You may not like me. We may be out of coffee. There may be a lot of factors. It's not just me saying, go get me a cup of coffee that's going to get a cup of coffee. And it's not just a peptide sitting in a cell that's going to make the collagen secreted or activate the immune cell or whatever it is that you want the peptide to do. Secondly, the peptide has to be able to get to the cell. And that is no small feat.
That's what I was thinking about.
That's not easy necessarily. Remember, the keratinocyte, which is what we say the viable cell, the living cell, that's down beneath. That's at the very lower level. And again, we have to get to the point where we really see the skin as the stratified, layered system that it is. And you guys know, and we all know here, and estheticians know, but the average person doesn't really recognize that the skin is stratified and the living cell is down below. And so to access the cell, which is really the very essence, the sine qua non, the essence of skincare is to get to the cell. Most of our skincare does not get to the cell, and this accounts for the general failure of skincare products. Getting to the cell is the key, and that is not a small feat under perfect circumstances, but with a peptide, you've got a water-soluble molecule. And so you have a barrier. Remember, we have a barrier to water, so it's not necessarily going to get to the cell even in the best of circumstances, even with, if, say, the stratum corneum was removed. But with the stratum corneum, that creates a major barrier. There are tricks that companies will use, and typically they're not going to put just a peptide in a skincare product. You'll see peptides that'll have like acetyl peptide, for example, or nonal peptide. These are fatty molecules that are attached to the peptide, the thinking being that the fatty molecule will pull the peptide down and the peptide will have its activity, will be more likely to have its activity. Nonetheless, as I say, there's multiple factors, not the least of which are the health of the cell itself. Because you see, if the cell is not healthy enough to make collagen, or if the raw material for making collagen is not present, or if the cell's membrane where the ear is located, the receptor is located, is not functional, you're not going to get an effect, nor should you get an effect. You don't want to put your foot on the gas if you don't have any oil in the engine. In other words,
that's a good analogy,
right?
too.
If you put your foot on the gas to try to drive a chemical reaction, but you don't have enough oil in the engine, you're going to burn out the engine. Now, it typically isn't going to happen because, as I say, the cell has fail-safes to prevent itself from being driven or overdriven if it's not appropriate. Nonetheless, it's not necessarily a good thing to make things happen. The body has a certain wisdom, as we talked about last time. You want to respect the body's wisdom. And this is why, to me, creating an environment, a milieu that the cell is sitting in that is conducive to the cell's health is the priority.
And preventing that toxicity, like you had mentioned,
keeping the area clean, making sure there's nutrients present, making sure the cell feels comfortable enough in order to make collagen. Yeah, yelling at the cell and putting the command molecule, if you want, the cell, that can help if the cell is perfectly, if the milieu and the environment for the cell is perfectly set up for the cell to grow. But given our environment, the toxicity we swim in, our nutritional deficiencies, our poor diets, there's a lot of things that compel the cell to not want to have to make collagen, to not want to have to divide, to not want to have to do whatever the peptide is commanding it to do. Long story short, theoretically, putting commands in the skin, if you will, and you understand what I'm saying?
Yeah.
Commands. Putting commands in the area theoretically can have an upregulating effect, which is what we want to do. Upregulating meaning stimulating activity. But because of all the other things that have to be in place, it doesn't necessarily follow that just because a peptide is associated with making collagen, that putting that peptide in the skin is indeed going to make collagen. Now, I should also tell you, and I know you wanted to ask me something, before we get to that, there's several types of peptides. There's one that we've been talking about called a signaling peptide. Signaling is communication. But there's other peptides that are carrier peptides, and these are peptides that carry things into the cell. Those work a little bit differently, and the most famous one, of course, is copper peptide. You probably heard of that. And that delivers copper in addition to having its own peptide effect. The peptide that is carrying the copper also has a beneficial effect. But basically, that's to deliver copper to the cell. And copper is a major player in the production of collagen and connective tissue. And then the third kind of peptide, which is the one that you were just talking about, you felt the twitches, that's called a neuropeptide.
Oh, I was wondering. Okay,
and
so
those have some really interesting benefits. You'll hear them referred to as Botoxlike. Have you?
Oh, I've heard of that.
Yes, these Botox-like peptides affect neurology. Now, wrinkles are caused by a tightening, the release of neuropeptides, or the release of something called acetylcholine, which is a natural neurosubstance, we'll say. It's not really a peptide, it's a neurosubstance that is associated with contraction and relaxation. So when we have wrinkles, there's a lot of acetylcholine present, and the skin gets tight and the wrinkles become more prominent. Botox works by dumbing down that system, causing a relaxation, so much so that you can't breathe and you end up dying. But these Botox-like peptides have a similar effect to Botox. By the way, Botox works by dumbing down this tightening effect and causing a relaxation of everything, so much so that you can't even move your face. The Botox-like peptides have a similar effect, not as powerful as injecting actual botulism toxin into your skin, but similar in the sense that they can block the release of this acetylcholine, temporarily causing a relaxation of wrinkles. Now, I would suspect that the reaction that you had, that twitching reaction, was the end result of a neuropeptide that was affecting the acetylcholine in the neurology of your eyelid. Under ordinary circumstances, or under positive circumstances, what you would have is a tightening under the eyes. And these neuropeptides, the most famous one is called argireline. You may have heard of that one. There's another one called SNAP8. And those are the two most famous ones. Those have this really kind of dramatic relaxation effect when you put them on topically. But again, the real problem is getting it to leave the skincare product and getting it into the skin, which is why if you use these peptides with microneedling, or if you use these peptides with iontophoresis, or use these peptides with any kind of driving system, that's where you're really going to get the maximum benefits.
What is ionphoresis?
It's electricity, basically.
Oh, okay.
It's, like a galvanic kind of thing. It's a little different than galvanic, but it's electricity. So using electricity, or using injections sometimes, or using a post-microneedling, these are ways that you can get peptides into the skin. Still, you have to have the milieu appropriate, as we were saying, but at least you'll bypass the stratum corneum and you'll be more likely to get the peptide to the viable cells at the basal layer.
So traditionally, we're using peptides for an anti-aging effect, and we've heard a lot of extrinsic reasons why the cell may not be receptive to these peptides. But what about intrinsic reasons? Like traditionally, your cell is just old now and it doesn't want to accept that peptide, or it sees the peptide as like a invader.
It won't respond.
Is that possible?
It won't see the peptide as an invader necessarily if the molecule is small enough and recognized. And typically they use molecules that are already in the skin or similar to things that are in the skin. But your point's well taken. If the cell is old, you can only do so much with yelling at it. It's like, if you have an elderly guy and you say, run, it's not going to help, right? So yeah, you can only do so much, which is why to me as a healthcare professional, and I don't consider myself that much of a beauty professional as much as I'm a healthcare professional, I'm saying, let's make the body healthy. Let's make the skin healthy. And, you ever hear that expression, how people have to reach up just to touch the curb? We're so below baseline with our health because of our nutritional status, because of the kinds of foods we eat, because of digestive health issues, because of psychological stress issues, and because of toxicity in the air, cigarette smoking, sedentary lifestyle. There's so many ways that we can improve the health of our tissue using vitamins, using nutrients, using lifestyle strategies, that it seems like peptides, if you have everything perfect and everything's done right, then maybe the peptides might help. But again, getting to the cell then becomes a problem. And that's why you want to be using it with not so much in skincare products, but post-procedure.
I just want to put a bug out there. The lifestyle changes that you are saying, that's difficult. Smearing cream on my face, that's easy. Just going to put a point.
But you don't get the same benefit.
I know. But
and you know what else? When we touch our skin, we secrete feel-good chemicals. So the kind of idea that we have about rubbing creams on and, that feels nice, there's a sensuality that's associated with that has a positive effect. Positive effect on the immune system, positive effect on blood flow, positive effect on mood. So there's a reason for applying. I
like that.
Yeah, there's a reason. Enjoy the sensual nature of using creams and oils and lotions on your skin, but don't conflate the sensual nature and the pleasure that you get from applying it and literally touching yourself. Just touching yourself like this feels pleasurable, but we don't want, and there's nothing wrong with that, but you don't want to conflate that necessarily with having an effect on your skin or on your skin cells.
A major dramatic effect.
Yes,
right.
Yes. So if you're going to use topical products, peptides are good, but to use them ahead of vitamin C or alpha hydroxy acids or retinol, the tried and true active ingredients that are either hormonal or nutritional, it seems like putting the cart ahead of the horse, it seems like to me. Helping your body make peptides, using peptides, giving the body raw materials for making peptides is important. And of course, that's where protein comes in and the appropriate proteins. Also, there are foods that contain active peptides. Lots of foods contain active peptides. Eggs contain active peptides. Beans contain active peptides. Pretty much all foods contain active peptides.
Is it any food that has protein in it? Or
pretty much all protein foods are going to have some peptides. But when you cook a food, to the degree you cook it, you denature the peptide. You break up the peptide. So heat processing has a tendency to break peptides up. But eggs, for example, are one of nature's richest sources of peptides. And dairy are also rich sources of peptides. And when you think about it, these are life-giving foods. An egg is going to become a life, and dairy is going to become a life as well. So the life-giving foods tend to be the richest in peptides. And then also, I should say that the endocrine system, the hormone system that goes from the brain or the various organs through the bloodstream to other organs and other cells, that's not just based in peptide hormones. Peptides are one class of hormones. There's also fatty hormones. Fatty hormones, typically we call them steroid hormones. Those are slightly different. Peptides are much smaller than steroid hormones, and they're much quicker acting than steroid hormones. They're very short. So I don't want people to confuse the steroid hormone system with the peptide hormone system. Those are slightly different. Peptides, because they're water soluble, are used very quickly. They're broken down very quickly. Steroid hormones have a much more long-lasting building effect. Peptides are for quick acting kinds of things.
So they go through your system quicker when you say that?
Absolutely. They go through your system quicker.
Okay.
And that's when you're taking them orally.
Yep.
Now, steroid hormones apply topically. I don't know if I don't want to digress too much, but steroid hormones apply topically. Progesterone, estrogen, testosterone, those have long-lasting, powerful effects, much greater effects than peptide hormones, than peptide molecules or peptide signaling molecules, because they're fatty and they're bigger and they last longer in the cellular area than a peptide hormone would.
So they can get through the barrier.
They get through the
easier.
skin. They have longer effects. They actually go into the cell. Peptide hormone will sit on the outside ear. A steroid hormone will actually go into a cell. And not only that, go into the nucleus of a cell where it will affect the genetics. And that makes it a whole...
Oh, I just love that.
That's a much more powerful thing than a peptide hormone, even though we call them both hormones. And what we're talking about here cosmetically are not really peptide hormones because they're much smaller. They're peptide signaling molecules, they call them.
It's always good to see that comparison and contrast. So.
Yes, and I wanted to be clear about that.
Yeah. Okay, you guys, that is going to wrap up today's show. And as always, if you're not an ASCP member, join today at ascpskincare.com/join. If you like this episode, make sure you subscribe today so you never miss it, okay? And details from what we discussed today will be in the show notes. And if you just can't get enough of Ben, and who can't, check out his blog at pharmacistben.com. And that is it. Have a fantastic, beautiful day.